So in today's lecture we are going to discuss the impulse and the impulsive force, right? So what is the impulse? You may write the heading impulse. The impulse is a vector quantity, right? So to understand the impulse, I take one example. For example, if this is the mass m, right, the force F is applied. In the Newton's laws of motion, we have applied the force, and because of this force, it acquires some acceleration, and after some time, it acquires some velocity. Is it clear or not? So suppose this is the case 1. Now I consider, suppose, another case where there is a ball and there is a bat, right? If we hit the ball by this bat, what will happen? The initial momentum of it is at rest, initial momentum therefore is 0, and because of hitting the bat, the ball will acquire some velocity, and if the friction is not there, it will continue to move. All right. So now you tell me, what is the difference between this case and this case? In this case, the force is continuous, is acting, right? Continuous force is acting for a long time. But in this case, the bat hits the ball and the time of contact is very small. Contact time is very less. Very less. How much less it is? In microsecond, in millisecond, like this. Are you getting on or not? So, and after that, there is no force acting upon the ball. So in this case, very high force acts for small time interval, for very less small time interval. Is it clear or not? So this type of the force which acts for the very less interval time, or the contact time is very small, is called impulsive force, right? Impulsive force. And the change in momentum is called the applied impulse, and the impulse is nothing but change in momentum. Are you getting or not? Yes. Impulse is nothing but change in momentum. It is a vector quantity and is given by I is equal to delta P upon delta T. Are you getting? For example, right, the if you if we consider the Newton's second law, rate of change of momentum, all right, so dp is nothing but f dt. Small interval is for a small interval time, the small elemental change in the momentum. If you integrate this for time t1 to t2, you will get p1 to p2 integration, right? This is the change in momentum from t1 to t2 into f dt. Is it clear or not? So this is the change in momentum. Change in momentum is equal to what? Say area under ft graph. Area under ft graph it is, right? This is area under ft graph. Is it clear or not? So listen, one more thing. If we, before hitting the ball, what is the force on the ball? Say 0. After hitting the ball, the force is again 0. So very high force act for very small duration, like this. Isn't it? So if you want to find the impulse or the change in momentum from t1 to t2, you have to find the area. What is the area? Say ft dt, right, from t1 to t2. This will gives the change in momentum, right, delta p. And this is nothing but the impulse is equal to change in momentum is equal to area under ft graph if the graph is given, right? So impulse, this is called the impulse, and this force is called impulsive force. Is it clear or not? This force is called impulsive force, right? The impulse is vector quantity. It is vector quantity, and SI unit is, if you consider delta P according to this, kilogram meter per second, and if you consider ft dt, it is Newton second. Is it clear or not? Now copy this. So this is the difference between the normal force, and this is the difference between the impulsive force. The impulsive force is very high in magnitude and acts for the short duration. One more example I am giving, and this is the hitting the football, right? hitting the football. Can you give more examples for impulsive case, impulse force? Yes, give me some more examples. For example, for example, hitting the ball by the ball. If this is the ball, are you getting? And you hit the ball, and when it hit and come back to this. So the time duration between the contact with the ball and the ball is very small. Therefore, it is the case of the impulsive force or the impulse. Now, I'm giving you a question. Suppose this is the bat, right? And there is a ball. The mass of the ball is suppose 200 gram, 250 gram, right? The bat hits the ball, bat hits the ball, and time of contact t is equal to a 2 millisecond, very small. Find the impulsive force. Find impulsive force if ball acquire the speed 100 meter per second. Is it clear or not? This is the question, right? So I'm writing the solution. What does it mean? Initial momentum is what of the ball? Say 0 because it is rest. Final momentum is what? Say m into v2. The mass is 250 gram, 0.25 kg. The speed is 100. It is equal to 25, right? Kilogram meter per second is the momentum. So the force is equal to rate change of momentum. That's it, right? So the change in momentum is what? P2 minus P1 and the total time, right? So P2 minus 25 minus 0 and total time is what? Say 2 millisecond. 2 into 10 to the power minus 3. So this is 12.5 into 10 to the power 3 Newton. So this force, impulsive force, is 12.5 kilonewton, which is very high in magnitude, acts for very short duration. So this type of force is called the impulsive force, and the change in momentum, right, in this case is called the impulse. Copy this. Okay, can you find the impulse in this case? What is the impulse in this case? Please tell. The impulse is nothing but, if you are asked to find the impulse is nothing but change in momentum, right? Change in momentum. So the magnitude is P2 minus P1. This is 25 minus 0 is equal to 25 Newton second. The impulse unit may be the Newton second or kilogram meter per second. Both are the correct answer. Do you understand this thing? Right. One more example. Listen one thing. Suppose this is the wall, right? If this is the wall, all right, and the ball of mass m is coming with the velocity v1. Are you getting? When it hits the ball, it rebounds with the speed v2, right? So why the speed, the velocity direction is changed? Because when it remains in contact with the wall, so the impulse is imparted by the wall on the ball, right? Also the same impulse is imparted to the wall, right, by the ball. Are you getting or not? So in this case, what is the impulse? Right, what is the impulse? If you take this is the positive direction, right, or plus x direction, because impulse and momentum are vector quantities. So impulse is nothing but the P2 minus P1, and it is equal to what? V2 minus V1. Is it clear? So although this is the impulse, but the thing is that if this is V1, this direction is positive and this direction is negative. So if it is magnitude V2, so I will write it minus V2 and minus V1. So the impulse is nothing but minus m V1 plus V2. This is the impulse applied by wall on the ball, and negative sign shows the impulse. This is the impulse applied by the wall on the ball, which is in negative direction. Are you getting or not? But generally many times we take the magnitude. So V1 plus V2, the magnitude is m, V1 plus V2. Is it clear or not? You will remember this. And if the special case, the no loss of kinetic energy during the collision, the V1 plus V2, then the change in momentum, which is equal to applied impulse is equal to m. This is V1 V plus V, and it is equal to 2mv. Is it clear or not? Copy this. So if the ball is going in a straight line and rebouncing in the same straight line, there is the change in momentum, and you must remember. But sometime the ball may hit the wall at some angle. Listen one thing. If this is the mass m, and the mass m, the ball is hitting at this point with the speed v1, suppose, and this is the angle theta. All right, this is the angle alpha, you can assume. Are you getting? If this is angle alpha, so this component is what? You tell me. This is the v1 cos alpha, and this is v1 sin alpha. After hitting the ball, the velocities change because the wall in the contact apply the impulse in this direction, and this impulse in this direction. Are you getting? Sometime the impulse is written as, right, ndt, right, or sometime it is written as fdt. What is the impulse? Impulse is nothing but fdt, right? So after this, after rebouncing, after hitting, the ball return to with the velocity v2, right? Suppose this angle is beta. Are you getting or not? Right, this angle, assuming the no change in the angle, right, this is the impulse, and the change in the velocity, and the velocity become v2. Are you getting? This angle is the same. It may be the different, or it may be the same. I'm assuming this is the different. Is it clear or not? And the velocity become v2. The magnitude of the velocity may be same or different. I am assuming the different. So this is v2 cos beta, this is v2 sin beta. All right, so you tell me in which direction, if I assume this is to be the x, this is to be the y axis, in which direction the impulse is imparted by the wall on the ball? In this direction, negative x direction. So if the impulse is imparted in this direction, the momentum in this direction will not change. So in y direction, no impulse. You understand? No impulse. If in y direction is no impulse, this is only the impulse in the x direction, in this direction, no change in momentum, right? Change in momentum in y direction is what? 0. So what is the initial momentum? That is p initial in y direction, p final in y direction. What will you write? Initial momentum is mv1 sin alpha must be equal to, this is the mv2 sin beta. Is it clear or not? This is the equation number 1, right? Now if we consider the x direction, the momentum is what? In the x direction, what is the momentum? Say mv1 cos alpha. When it is moving back, right, after rebouncing, it is what? mv2 cos beta. So if it is in this direction, what is the change in momentum? They will be added, this minus this. So the change in momentum, if you take, this is the positive x-axis, this is the positive x-axis, p2 minus p1 is the change in momentum. p2 is what? Minus mv2 cos beta, minus, what is the p1? Cos alpha. If you take m common, v2 cos beta plus v1 cos alpha. That is the thing. So this is the change in momentum, which is equal to the applied impulse. This is applied impulse by wall on the ball, right? What is its direction? Say minus. Minus mean the ball is hitting the ball in this direction. Are you getting or not? So this is the case. And if you consider the magnitude, right, the magnitude is this, m v2 cos beta plus v1 cos alpha, right? In this special case, there may be many cases, right, alpha and beta. If alpha and beta are equal, is equal to theta, then what is the change in momentum? V2 plus V1, and this is the cos theta. If V1 and V2 are also equal to V, so then it become 2mv cos theta is equal to change in the momentum is equal to applied impulse. Is it clear or not? Copy this. So this is the impulse applied by the wall on the ball, right? This is the one type of the question. Okay, for example, you will remember this, right? If this is the ball is hitting the mass v1, right? It is coming with the velocity v2. What is the change in momentum? You will say m v1 plus v2. Is it clear or not? For example, I'm giving you one more example. If this is the ball which start from rest and from height 100 meter, it falls and it hits the ground. When it hits the ground, it collides with the ground, it rebounds, right? Suppose the velocity when hit before hitting the ground is v1 and it hits with rebounds with the velocity v2, so it goes up to only 60 meter. Is it clear or not? And the velocity becomes 0. If time of contact between the if the time of contact is 1 millisecond, find the impulsive force applied by ground on the ball. The question is clear or not, you tell, right? So is this question or clear or not, you tell? Understood? So when the ball, if this is the height h2, this is height h1, how to solve this? You just find the velocity v1 and v2, find the change in momentum, divided by delta t, then you will get the answer. First copy this. Okay, so how to solve this question? We can find the velocity v1 using the equation of kinematic equation, right? First equation of motion first. The v1 square is equal to u square plus 2gh. I think you know this is the initial velocity, it is released from rest, so the u is 0, 2gh h1, right? 2 into 10 into 100, so this is the v1 square. So v1 is what? This is root 20 into 1000 and 4, this is 2 into 10 into 5, so 20 root 5 meter per second is the speed, right? And what about the v2? Again, this is, suppose this is the h2, I assume this is the h1. So for v2 finding, v square is equal to u square minus 2gh, you will apply. The final velocity is what? Here it becomes 0. The initial velocity is v2 square minus 2gh2, right? So v2 square is equal to root 2gh2, so it is equal to 2 into 10 into 60, so this is equal to 20 root 3 meter per second, right? Because yes, 20 root 3 meter per second. So can you tell me what is the magnitude of change in momentum when it hits? The mass is m, right? You may assume the mass of the ball is 100 gram, right? It is not given. You may assume the mass is 100 gram. So what is the change in momentum, you tell? Say m v1 plus v2. Did you understand or not? Right. So it is 0.1. v1 plus v2 mean 20 root 5 plus 20 root 3. This is 20 root 3. So this is 2 into root 5 plus root 3. All right. This is the change in momentum. So this change in momentum is nothing but equal to applied impulse. If you want to find the force, the change in momentum divided by time of contact, 2 root 5 upon root 3. What is the time of contact? Is 1 millisecond, right? It is 3. So this is 2000 into root 5 plus root 3. It is root 5 value 2.23, root 3 value 2.73. 2000 into this is 0 0, right? 3 और 3 6 9 और 3.96. So this is 20 into 3.96 and you can multiply इट इज 0, 6 दूनी 12, 9 दूनी 18 और 1 19, यहाँ से लग गया है 3 दूनी 6 1 7, 7.92 kilo Newton force is applied, impulsive force is applied on the wall due to the ground in this direction. Is it clear? Copy this. Right. Okay, so these type of the question were asked. So one more type of the question is given, like sometime suppose the mass is given as the 2 kg of a ball and its velocity given as a function of time t, 2t square I cap plus 4t j cap, right, meter per second. So this is the velocity and the mass is given as a function of time t. You have to find impulse imparted by force, right, from t is equal to 0 to t is equal to 2 seconds. So this is the question. So how to solve this? Right, the impulse is nothing but change in momentum, right? Impulse is nothing but change in momentum, which is equal to m v2 minus v1 vector. Is it clear or not? So mass of the body is given as 2, so v2 and v1 we have to find. How to find the v2? The v2, this is t2 and t1 I can assume. So what is the velocity at v2? When you will put t is equal to 2 seconds, so this is 8 I cap plus 8 j cap. This is the velocity v2 after 2 seconds, and at t is equal to, right, 0 second. When you will put 0, it is 0 also 0. So 0 plus 0, it is 0, right? So the impulse is nothing but m v2 vector 8i plus 8j minus null vector, or you may write only 0, right? So this is the impulse is equal to 16 I cap plus j cap. If you want to take the magnitude, then the impulse is nothing but 16 root 1 square plus 1 square is equal to 16 root 2 Newton second is the impulse imparted by the force when the velocity is given as a function of time t in this way. All right, so sometime the question may be given like this. Copy this. In some question, what will he give? Right, sometime he will give the impulse imparted and the initial velocity they will give in the question, and you have to find the final velocity. Are you getting or not? Or sometime they may give the force also. For example, sometime suppose the mass is suppose the 4 kg, the mass is 2 kg, and the initial velocity is 2i minus 4j meter per second. Are you getting or not? And if the force F is equal to, suppose this is the 2i plus 3j cap, Newton is applied for 2 seconds, right? Suppose it is 4 seconds. Find the velocity. Find the velocity after 4 seconds. Find the velocity after 4 seconds. So this is the question. Is it clear or not? That for 4 seconds. So how to solve this question, right? So although this question is of Newton's laws of motion, right, it is not the question of the impulse or impulsive force, because the time duration is very long, but still the F is equal to rate change of momentum is equal to applied force we can apply. So the rate change of momentum is equal to F delta t. Is it clear or not? So what is the force? This is 2i plus 3j and the time is 4 seconds. The change in momentum is p2 minus p1. This is given in your sheet, that is why I am explaining, but it is not the case of the impulse or impulsive force. Why? Because the time duration is very long. Is it clear or not? So we have to find the m v2 vector minus v1 vector it is. Is it clear? So what is the m? It is 2 kg. v2 vector we have to find, and the v1 vector is minus 2i minus 4j. Is it clear? Is equal to 4 into 2i plus 3j cap, right? Like this. So it will cancel out. This is 2, 4i plus 6j cap. This is v2 vector and minus 2i plus 4j cap. When you will simplify, you can get the velocity 6i cap plus 2j cap meter per second is the final velocity for this question, when the force is applied for large time, initial velocity and the mass is given, right? So this is the question. Copy this. For this is the one type of the question. The another type of the question you have done in the Newton's laws of motion, just I am repeating. They have given the graph, right? For example, this is the force versus time graph, right? This is the force versus time graph. They will give like this, right? This is 0 to 2 to 4 seconds. Suppose this is the 6 second, and the maximum force is suppose the 50 Newton. Is it clear or not? So at t is equal to 0, if at t is equal to 0, the velocity of the particle, you may assume this is the 2 meter per second. Then find the velocity after t is equal to 6 second, right? That is the thing. The mass, you can assume the mass of the ball is assumed to be the 1 kg. Is it clear or not? So then the same thing is that it is the graphical situation, right? Although the question says again of the Newton's second law, but it is given in your book. That's why del F is equal to delta P upon delta T, right? The change in momentum is nothing but F into dt. This is the dP is equal to dt, right? So the area under FT graph gives what? The change in momentum. P2 minus P1. What is the area? From where to where you have to find the area? From T1 is equal to 0 to T2 is equal to 6 seconds. If in the question for the less time interval is given, for example 0 to 2, then you will take this area only. Understood or not? So what is the area? Area is nothing but 1 by 2. This is 6 into 50, right? This is 3 is equal to 150, right? Area unit is not meter square over here, right? What is the unit of the area? Can you tell in this case? Varsha? Newton second. Yes, Newton second, right? This is second, this is Newton. So Newton. Area does not mean here the meter square, right? So this is the change in momentum is 150. P2 minus P1. What is the P1? This is the M 1 kg. This is the V1. So 1 into 2 is equal to 150. So the P2 is also equal to M into V2, right? M in 1. So V2 minus 2 is equal to 150. So the velocity becomes 152 meter per second. Is it clear or not? But sometime the graph is given like this. If this is the ft like this, right? So if this is the f versus time graph, right? You have done this question. So this area is to be taken with the negative sign. This is the positive sign. That's the thing. Understood? So this area is taken to be with negative sign. This is positive area and this is negative area. Is it clear? Copy this. So this is the some questions of the impulse momentum theorem. You can say impulse and the momentum theorem. Impulse is equal to the change in momentum. Is it clear or not? Right. Ink. Okay. Now we are going to discuss the conservation of the linear momentum. Right. You may write the heading conservation of linear momentum. What is the conservation of linear momentum, you tell? The conservation of linear momentum. For example, if you consider the external force is equal to rate change of momentum, right? If external force applied is 0, then the rate of change of momentum dp upon dt is what? 0. It means the momentum is constant. What does it mean? The initial and final momentum are same. Is it clear or not? So this is called the principle of, this is called, that is, if external force is applied, that is, if no external force is applied, right? The change in momentum, right? Change in applied, then initial and final momentum final momentum are same. No change in momentum. Is it clear or not? So this is the principle of conservation of linear momentum. Just copy this. For example, the simple example we are doing. Suppose the explosion of bomb, right? Explosion of bomb, right? This is the conservation of linear momentum is also valid for the system of particles. Explosion of bomb, if this is the capital M, right? Suppose this is the capital M, and after explosion, how the explosion occurs? When you ignited the material inside the bomb, right, due to the chemical reaction inside in it, right, the internal force are produced, and because of internal forces are produced, right, it breaks in the two or many parts, right? Suppose this is the one part and this is the another part. Are you getting or not? This is the before explosion, this is the after explosion. So in this case the initial momentum is 0, right, because it is at rest, and after that the velocity v1 and v2 are required. The final momentum you may write m2 v2 minus m1 v1, right? m1 v1, if you take this is the positive direction. Is it clear or not? Since no external force is applied, external force is what? 0. Therefore the initial and final momentum will be the same. What is the initial momentum? Say 0. What is the final momentum of this system? Is m2 v2 minus m1 v1. So it will come this side, so m2 v2. So this is the relation between the m1 v1 and m2 v2. Are you getting or not? Copy this. I'm taking one example, right? Suppose this is the 10 kg block, right? It is at rest initially, and it is 2 kg block, right? It explode in the two parts initially. Suppose its velocity is 10 meter per second. What is the velocity of this part? So what will you apply? Simple, m1 v1 is equal to m2 v2, right? m1 is what? Say 2 v1, m2 is 8 into 10. So the speed of this particle will be, the part will be asked. So this is 40 meter per second. Is it clear or not? So it is very clear that the velocity acquired in this process is inversely proportional to mass. What does it mean? If the mass is lighter, right, the speed will be higher. How much it is? 40. And if the mass is higher, the speed will be lesser to conserve the linear momentum. Is it clear or not? Now you can copy this. So this is the very simple question. Now we can to discuss, for example, suppose we have the 10 kg bomb, right? This is the 10 kg bomb. Initially it is at rest. It explodes in 3 parts. Explodes in 3 parts, right? 3 parts, right? And what are those parts? This is the 3 kg, right? This is the 2 kg, this is the 3 kg, and the another part, this is the 2 kg moving with the 50 meter per second in this direction. This is the 3 kg moving in this direction 100 meter per second. So there is another part, the third part is the 5 kg, right? So it will move in this direction definitely, because the center of mass should remain on the same position. Initial momentum is, if it is 0, the final momentum must be 0. If we assume this is the y-axis, this is the x-axis, right? The question is as shown in figure. You have to find velocity of third particle, third part. Is it clear or not? This is the question. Copy this. So we can solve by applying we can get the velocity applying the conservation of linear momentum. All right. So listen one thing, I'm making in this direction. I don't know the velocity of this particle v3. So I'm assuming this is the v3, this is the v1 in vy in the y direction, this is the vx in the x direction. All right. So initial momentum for this block, because the motion is in 2 dimension, so I will conserve the momentum in x direction and y direction separately, right? So first apply the conservation of momentum in x direction, p final and the px direction. Is it clear or not? So initial momentum is 0 in x and as well as in y direction. So what is the final momentum in x direction? Listen, this is the positive direction, this is the 5 kg, right, in the vx direction. So it is just only in the y direction, minus y direction. So for in x direction, this is m1 v1, right? What is mass? 2. What is the velocity? This is 50, right? For this mass, what is the momentum? Minus 5m into vx. Is it clear or not? So it will come this side, 5vx is equal to 100. So vx is equal to 20 meter per second. So the velocity component of this third part in x direction is 20 meter per second in negative x direction. Is it clear or not? Also, apply the conservation of momentum in y direction. So P final in y direction, P initial in y direction are equal. So what is the initial momentum in y direction is also 0, right? So P final in y direction, it is moving in this direction. So 5 into Vy, right? 5 into Vy minus 3 into 100. So this is 5 Vy is equal to 300. So Vy is equal to 60 meter per second. Are you getting or not? So therefore the velocity v3 vector I will write. How I will write? This is the minus 20 I cap minus 60 j cap is the correct answer. Are you getting or not? So this is the method 1 to solve this question. Are you getting or not? So the second method, how can we apply? Listen, the method 2, P initial and the P final. What is the P initial? Say 0. What is the P final? What is the P final? This is the M1, M2 and M3. So 2 into, this is 50 I cap. The final momentum of this 2 into M into V. This is 50 I cap. Plus the momentum of this mass minus, this is what? It is minus j cap. So plus 3 into minus 100 j cap plus v3 vector plus its momentum is what? 5 into v3 vector. Are you getting? So this is minus 5 v3 vector is equal to 100 I cap minus 300 j cap. So directly the velocity you can find. This is the v3 vector is equal to minus 20 I cap plus this is what? This is minus plus how much it is? 60 j cap. Are you getting? Wait for 1 minute. This is the Vy direction. It is in the positive direction. So this is the plus 60 j cap, right? So either you do in this way. This is the plus j cap direction. This is the minus I cap. So here the plus. So according to this method also, the same velocity of the third part you are getting. Copy this. Listen, one more thing. This is the one type of the question, right? The speed of okay, now we will discuss the conservation of linear momentum through one more example, the speed of recoil of gun, right? The speed of recoil of gun. Suppose this is the gun of the mass m and there is a bullet of small m which is at rest here. Are you getting or not? When the ignition takes place, when you press the trigger, right, due to some ignition, the internal force are produced, internal energy is produced, due to which it acquired the velocity. When it come out from the gun with the velocity, suppose v node, so initial momentum is 0. So therefore to conserve the linear momentum, this gun is recoil with some velocity, right, in the backward direction. So this is the v dash m. Are you getting or not? So this speed is called the recoil speed of the gun and the P final must be equal to 0. What is the P final in this case? If you assume this is the positive direction, it is mv naught minus mv dash. So the P final and P initial must be same. M small m into v naught, v dash must be 0. So v dash is equal to m upon capital M into v naught. So this is the speed of the recoil. All right. So this type of the simple question are asked, but sometime what they give, uh, suppose this is the tank, right, and there is a cannon, right, at fire some angle theta like this. Is it clear or not? So what will they give? They will give the speed u or v like this. There is a tank of mass m, and there is a uh, what you say, this is the bomb, right, or the some spear. So it is initially at rest. So when the spear come out from this with some velocity, are you getting like this? So it will be moving in this way. The mass m, it's a small mass m, the u, and it come out from the cannon with the speed u at angle theta. So what will happen to this? It will move in this direction, m into v dash. Is it clear or not? So if you consider this is the system, the initial momentum remains constant in x direction, right? Momentum, initial momentum is 0 in x direction as well as in the y direction, 0. But when a cannon, from the cannon, this spear or this bomb is come out from this, so no force exerted on this in x direction, while the normal force is exerted, the impulse and dt is applied on the on this by the rod in this direction. So we can apply only the conservation of linear momentum in x direction. So what is the final momentum in x direction? So if you assume this is the positive x direction, this is m u cos theta, this speed is u cos theta, and this is the u sin theta, mu cos theta minus m into v dash. So the p final in x direction must be p initial in x direction, which is must be equal to 0, and the final momentum is mu cos theta minus m into v dash. Is it clear or not? So the v dash comes to be mu cos theta upon m in this case. Is it clear, Varshas? Now I ask one question, right, and you have to answer. Listen one thing. The important point here you can write down. This v naught and v dash, are the velocities with respect to ground. You must remember this. With respect to ground, the initial momentum is 0, say with respect to ground. You must mention this. The final momentum is m minus mv naught minus mv dash, right? This is also the with respect to ground. This is very important. For example, you may confuse. Suppose this is the cannon, this is the tank, and this is the cannon, or horizontal direction. So, right? There is a mass m of the bolt. Suppose this is the 5 kg, right? And this is of the 100 kg. Suppose this is the tank of the 100 kg. You may assume it is at rest if the the bullet, we can say, if the bullet or the block of the spear, right, spear comes out, spear leaves the cannon, with velocity, right, 200 meter per second with respect to cannon, relative to the cannon, or relative to the cannon. Understood or not? This is the cannon. Find the recoil speed. This is the question, right? I will give you 1 minute to think about the recoil speed of cannon, right, or tank, you can say. Okay. This speed is given to the relative to the cannon. Do you understand or not? Relative to the cannon means this is the cannon I am assuming, right? What does it mean? If this is the cannon, it is moving with the speed v dash. Are you getting or not? And this is the spear, so it is moving with. When you are sitting over this and you are looking this, are you getting or not? So with respect to this, it is moving with 200 meter per second. So can you tell me, with respect to ground, the same velocity it will have? With respect to ground, the same velocity will it have? No. So it is the relative velocity given, while what you are applying m1 v1 is equal to m2 v2 is the linear momentum with respect to ground. So I have a very simple technique to solve this question. What will you do? If this is the m, this is the v dash, suppose this is the v1, or you may assume v2. If this is the m1, this is the v1. Are you getting or not? First, to solve this question in a simple way, you will assume what is the initial momentum? 0 with respect to, say, ground. Now it leaves the cannon, the ball leaves the cannon with the speed v1. This velocity you have to take with respect to ground. Are you getting? And this velocity of the cannon also you have to take with respect to ground. Are you getting or not? Yes, sir. So now we can write the relation. The initial momentum is equal to final momentum with respect to ground. Are you getting? So 0 is equal to m1 v1 minus m2 v2. So m1 v1 is equal to what? m2 v2. But what is the 200 meter per second? Can you tell? Yes, what is the velocity 200 meter per second? Is it v1? Is it v2? Or what else? V relative. What does it mean? No. Listen. One more thing. If this is the car, I'm just revising the thing. It is moving with 100 meter per second, and another car is moving with 50 meter per second. What is the relative velocity there? (150), right? 50. When they are moving in opposite direction, the relative velocities are added. Is it clear or not? If the car is going with v1, car is going with v2, what is their relative velocity? v1 plus v2. So 200, what is given as the 200? 200 is nothing but v1 plus v2. Now understood or not? Otherwise you will get the wrong answer. So m1 is what? Say this is m2, this is 100 into v2 we have to find. m1 is what? Say 5, and the v1. So we have the relation v1 is equal to 20 v2, and what we have to find? v1 I will put here. This is 200 is equal to v1 plus v2. I will put the value 20 v2 plus v2. It is 21 v2. This is 200. So v2 is 200 upon 21 meter per second. Is it clear, Varshas, or not? You tell. Yes. So you take care, the 100% they will give the relative velocity. They will not give the velocity directly with respect to ground. It may be, but the chances is very less, right? So copy this question. Very good question. Suppose, listen one thing. This is the capital M plank, right? And there is a person of a small mass M. Are you getting? There is no friction between the ground and the plank. When the person runs over this, what will happen? It will move this. Are you getting or not? If person run over the plank, with relative velocity u, right? Find the velocity of plank. Do you understand or not? If it is rest, both will remain rest, but when it will continue to move, it will moving to the backward direction or not? We have found the displacement also, but now in terms of velocity, it is running on the plank with the speed u. Relative velocity it is given, not with respect to ground. Always you have to take care of this. Then it will be moving to the backward direction. You have to find the velocity of the plank. This is the question. Is it clear or not? Okay, how to solve this question? Okay, first copy this. So I am giving you the idea. Very simple, right? Otherwise it is very confusing. Listen one thing. Suppose this is the person of mass m is moving with the speed v1. With respect to ground, you have to write the velocity. And also this capital M is moving v2 with respect to ground, you have to take. So now what is the relation between m1 v1 and m2 v2? Tell. With respect to ground, initial momentum is 0. So final momentum with respect to ground will be 0. Minus m1, right? This is the m into v2 minus, small m into v1 minus m into v2. So capital M v2 is equal to m into v1. These are the velocities. One is moving in this direction, one is moving in this direction. What is u? What is the u? Can you tell me? v1 plus v2. Is it clear? This concept is clear, or should I explain this further? Should I explain this? Should I explain this? Right, now you can do. What we have to find v2. So therefore the v1 value is u minus v2. I will put over here m into u minus v2. So m into v2 plus m into v2 is equal to m into u. So the v2 is equal to m plus small m is equal to mu. So v2 is equal to what? M upon capital M into u. Is it clear or not, Varshaz? This very similar question you will get in your sheet or some other books. For example, they will ask, for example, if there is a boat, right? There is a boat. The boat mass is suppose m, and the person is over there of mass m. They will say that the person jumped into the river with speed u relative to the boat. Person jumps, right, with speed u relative to the boat. You have to find the speed of the boat. Find speed of the boat, or you can say the velocity of boat. You understand or not? So how to solve? The same solution. The relative velocity is given of the person with respect to you. With respect to ground, this is 0. So when it jumps in the air, I will assume this is the m into v, and this is the boat. It will move definitely into this speed. So these are the velocity v1 and v2 we are taking with respect to, tell, v1 and v2 are we are taking with respect to ground. So therefore initial and final momentum with respect to ground you have to put equal, right? M into v2 is equal to n into v1. But what is u? The relative, yes, v1 plus v2 is equal to u. So v1 is equal to u minus u2, and the same solution you will get. So there is no difference between this and this. Are you getting or not? Yes. But the question problem become tough. In the SC Verma it is given, or in your sheet there will be the two person. When the first person jumps, find the velocity of the boat. Then after some time some other person from the jump, right? Then the velocity we have to find. Although other type of the solutions or the method to solve this question are very tough, but if you do in this way then it will very simple. Copy this.